Hi, good afternoon, everyone, and welcome to AtlanTec Festival 2021. We're back again for our seventh year and running a packed event across 5 days with 40 events and over 60 speakers. You can follow us on Twitter at AtlanTecFest and use the hashtag AtlanTec. We're interested to know what's of interest to our tech community of innovators and practitioners along Ireland's western seaboard, what we call the AtlanTec Gateway. These events that are supported by the tech community enable the sharing of expertise and knowledge. My name is Sarah King, and I've been a developer in Hewlett-Packard Enterprise for 10 years. I'm part of a team that is developing and supporting an automated chatbot that provides customer-facing services, including troubleshooting. I'm delighted to be here as your event moderator today. I'll be tracking your questions throughout the talk. You can use the Q&A function to ask Gary any questions about his talk. Q&A function can be accessed by clicking the button with the 3 dots at the bottom right-hand side of the page, that's the one beside chat, and just clicking on the Q&A text. In a moment, we'll hear from Gary Short about moving a data science team into the cloud due to COVID. Gary's the founder of Duncode Limited, a company specializing in building internet-scale data science platforms and teams to enable businesses to predict the future. A big thank you to our sponsors and supporters. Without their and your support, these events would not be possible. We're really looking forward to your questions and comments throughout the talk. And with that, over to you, Gary.
Thanks very much, Sarah. Thanks for that great introduction. It's great. And there'll just be a slight pause and then we'll start promptly. Must be the most Irish thing I've heard in a very long time. If that did make me laugh, if you just bear with me a second while this pops up, I will share my screen. There we go. It's working now. Had a little bit of a think to itself. It's grand. Okay, cool. So I'm hoping now you can all see my screen. Sarah, if you could just let me know.
See the screen, Gary?
Yeah, you can see it?
Yes.
Perfect. All right, so we'll crack on. This is the right talk. As Sarah said, we are going to be talking about moving a data science team to the cloud. So we're all in the right place. This is me. As Sarah said, I'm the founder of Duncode Limited, which specializes in data science and data architecture. As you said, we build internet scale platforms. We help to build or to train your in-house data science teams, bring them up to the cutting edge, and then we will help you predict the future using those platforms and those teams. So what we're going to speak about in this session is we'll look at the evolution of a cloud-based architecture that was designed and built hurriedly by Duncode Limited in order to support data science business as usual for one of our clients after COVID hit us. So this was a situation before COVID. It's pretty much the same as every enterprise you've ever been in. I'm sure there was all the little data science people and all of the data and all of the compute and everything that they needed to do their business. And we're all on-prem, all behind a firewall, everybody happy little soldiers. And then COVID struck and everybody was sent home. And this is pretty much what it looked like after that. Everybody's at home with their work laptop, all plugged in under domestic IP, all members of different networks, all completely disjointed and with no access to each other, no access to the data of the enterprise. For a data science team, pretty much useless, to be fair. There isn't much that you can do in this kind of situation. So the first thing that we looked at doing was to create a VPN which will allow all of our data science people to be able to reach the data of the company. Here I've got this icon here on the right hand side which says SQL, but that represents all of the data and everything that they need on the corporate network. So what we simply did was to set up a VPN so that the data science team over here in their domestic IP addresses come in, log on to the VPN, get a particular IP address from a pool that the VPN would give to data science people, and then use that VPN to have access to all of the data. And that worked pretty well, actually. At this point, the business have what they want. They have all of their data scientists have access to the servers and the data of the corporate network. So at this point, business is pretty happy. Unfortunately, cybersecurity are not happy at this point. So what cybersecurity are particularly not happy about at this point is the data over here on the right-hand side now resides on a machine outside, well, not necessarily outside of the network because you're still in a VPN, but physically it's outside of the network that they control. It's on a hard drive in someone's house. And the cybersecurity people are concerned about data leakage, they're concerned about GDPR issues, and they're concerned about reputationally damaging data leaking out into the public. So they pretty much said to us that we can't continue with this architecture and we have to make some changes. So here we have, and this is the start of a struggle of something that I'm sure everybody's aware of during the time of COVID, but became a theme throughout this evolving architecture, is trying to balance the requirements of the business to carry on business as usual with the requirements of cybersecurity, trying to keep not only in line with the law with regard to GDPR, but also protect the company from reputational damage and information leakage. And we can see that kind of imbalance between wanting the business to be able to go forward and InfoSec wanting to tighten up on everything and control everything is a kind of theme that we'll see through this. But right now, as we have this simple idea of users from outside of users at home with their corporate laptops accessing the data through a VPN wasn't something that that cybersecurity were going to allow to continue. Okay, so what we did with that then was we said we took that on board and we said, okay, to give you a bit more confidence in what we're doing, we'll start here from the left-hand side. This stays exactly the same. On the data science analysts are all still at home. They're all still behind their domestic IP addresses. They're still going to log on to the corporate VPN. They will still be given an IP address from a pool of IP addresses that the VPN manages specifically for data scientists. So that's a pool specifically for them. They'll be given that pool. And then with that pool, they'll be able to access VMs in the cloud. So in the center part here, we have the Azure cloud. And in here, we have the VPNs. And these, sorry, not the VPNs, these VMs are going to be their development machine. So a development machine in the cloud that they can set up how they want. And so what they're going to do is they're going to RDP through the firewall here. The firewall here is going to have all of the pool of IP addresses that the VPN will issue to data scientists, all whitelisted at the firewall here. So they can RDP straight through to these machines here, which in other aspects are very much locked down. We have a subnet here surrounding that, and we have a subnet here, and we have a network security group. And we can apply rules at the network security group level here, which pretty much will allow us to lock down these machines with regard to side-to-side communication and out to the internet communication if we want, in order to make cybersecurity happy. On the right-hand side, we still have our corporate data, but what we create now is a private link between the endpoints that we require in the corporate network and a private link through to these VPNs in the Azure cloud. So that was our first kind of cloud-based approach here. And this allows this allows our data scientists to RDP in here and then work on these machines here. And this overcomes the problem that that cybersecurity had, or the issue that cybersecurity had with regards to data leaking out of the corporate network here into the outside world over here. Now all that can happen is the data moves through this private link into a VM in the cloud, which is just an extension really of the corporate network. So to all intents and purposes, it hasn't gone anywhere. The network security group and rules within the virtual machine stop any downloading to removal of that data from that machine. So they can be quite confident now that data that's moved out of here only goes no further than the virtual machines here on the cloud. The data scientists are happy that they can get their work done on these virtual machines. So we've overcome the problem or overcome the issue that cybersecurity had with this idea of data leakage into the outside world. So at this point, we think everybody's happy. The data scientists are certainly happy. Infosecurity, cybersecurity are not happy again, and they raise another issue. And the issue that they raise now is that RDP is not secure. And we kind of, and I do apologize if you work in cybersecurity. You know, we in the data science side, on the business continuity side, and the architecture side, we kind of roll our eyes a little bit at this point, and we say, well, look, to be able to get in here, the user first had to authenticate against the corporate VPN and be given a known IP address from a pool only given to data scientists. So that's the first piece of authentication. Then to get into their VM, they had to pass through the firewall where it only had whitelisted the IP addresses in that VPN pool. And so that's another layer of authentication. So that's 2 layers of authentication. And then once onto these machines, they had to authenticate against the local machine in order to get on. So they have 3 layers of authentication that they and I do see the point of view. The point of view that cybersecurity put up was that security is something that's done in depth through layers. And we're quite right. I was quite right to point out the 3 layers that they do have, but actually they have a 4th layer, and this 4th layer, just using RDP, is not particularly secure. So we took that issue on board. And what we did at that point was we decided to bring in, we decided to move to a situation where we had cloud-based VMs with Bastion. Now, Bastion is a service that Azure offers. Microsoft have done one of these things that they do quite often now, and it does irritate me a little bit just because of the confusion that it does that it does create. So what they do is they take a concept in the IT world, and then they name a service after that concept. And from that point forward, you can't be too sure whether you're talking when you're having a conversation. You can never really be sure whether the person you're speaking with means the concept or the actual service. So one of the things that hit us with regards to architecture and data science, one of the first things was when Microsoft called one of their services Data Lake. And now that's great, but data lake is a concept in the data science world. So now when you're in a conversation with people, you don't know, you can't necessarily be sure from the context whether they're talking about, when they say data lake, whether they're talking about the general concept of a data lake or whether they're actually talking about data lake the service. And as if that wasn't bad enough, Microsoft then did it again with this idea of the Bastion service. So within architecture, there's this concept of a Bastion server, and what the Bastion server would do is it would kind of sit between the outside world and your DMZ, or between your DMZ and your segregated subnet. So basically, it sits between two subnets, and it kind of authenticates you as to whether or not you're allowed to have traffic or be on the network that you're trying to get into. So Microsoft introduced this new service, which is called the Bastion service. So it's that concept of an actual server or a group of servers, and they've wrapped that into a service, which is PaaS. It's platform as a service. You don't have to worry about it. It's just there. So what that allows us to do, and this Bastion service sits here. When you say I want to use the Bastion service within a particular resource group in Azure, what happens is it gives you that service, and it creates another little subnet within your VNet with its own network security group rules. Now, in general, you don't really have to touch this once it's set up, but you can, if you want, go in and modify and add your own rules. Obviously, the Bastion service won't allow you to remove the rules that actually allow it to work, but it will allow you to add extra ones that you want to monitor and to restrict traffic between this subnet here, which is the Bastion one, and this subnet here, which is now our segregated VM subnet where all of our VMs live. And what that Bastion service allows us to do is to do HTTPS into the Bastion service, and then from the Bastion service behind the scenes using the Azure backbone, the Bastion service will then use RDP between it and the virtual machines in our segregated subnet over here. It'll do the RDP communications this way, and then it will mock RDP over HTTPS this way back to our data scientists at home behind their domestic IP addresses. And so what that looks like to the users is basically an RDP session, but within a browser tab. So it looks like RDP in a browser. But what this does is it removes this part here, which was RDP, that our cybersecurity people were a little bit concerned about. And so now what we've got by way of authentication is we have our data scientists here behind the domestic IP. And what they have to do now, in order to connect to the VM here through the Bastion service here, what they have to do is they have to authenticate into the corporate VPN, get that IP address from that pool of IP addresses that only data scientists can have. Once they have that, they then travel through the Azure firewall, which has that pool of IP addresses authenticated, to Azure Active Directory in the cloud, and then they authenticate through that onto the Azure portal. And then once they're in the Azure portal, they will have access then to this VM here. They'll select that VM and they'll select connect. And instead of connecting through RDP as they did before, what they'll do is they'll select connect via Bastion. And then they will authenticate into this machine here through this route here. So now what we have is in a number of authentication steps. So firstly, we're authenticated at the VPN. Then secondly, we are authenticated at the Azure firewall with the IP address pool. Thirdly, we are authenticated through the Azure Active Directory to ensure that they have access to the portal and the VMs. And then fourthly, we have authenticated onto the machine to ensure that it's the individual person using their individual machines. And at this stage, I think everybody is quite happy at this stage now, because we have we have all of the business is in place, all of the cybersecurity in place. The data scientists here, they can have access from here on the left-hand side at home all the way through this via the virtual machines here where they actually do their data science work through the private link to the corporate data here. So at that point, business is happy, and at that point, cybersecurity are happy. So we're all happy people at this point. And time passes, and what we realize is over time that the business are not particularly happy here with this Bastion service. It does work, to be honest. It works quite well for what it is. And if you just want to follow this route through an RDP to a VM to check something, if you're an administrator and you want to run a script or something like that on a server, if you just want to do something temporary, it works pretty well. It's pretty good. But if you're a data scientist here and you live here on your laptop and you work here on this machine here, and your entire day is spent looking at an RDP session through a tab on your Google Chrome or on your Edge browser, that is not a great experience. And it's not a great experience to be working like that all day. And so after a period of time, we tried to get reports back from the users that were saying, well, actually Bastion can be a little bit slow, and that's true, it can be. And also, it's not a great user experience having the RDP session confined to a browser, to a tab in your browser. So at the start, both the business and cybersecurity were happy. Over a short period of time, it became clear that the business weren't really happy with using Bastion in that way forward. So the next thing we looked at was PIM and JIT. So what PIM and JIT allow you to do is it replaces Bastion, and what it allows us to do is to inflate privileges for a while and have a JIT which is just in time. So we don't have this RDP. What InfoSec were concerned about when we had RDP and their idea of its insecurities was this idea that it's there all the time, it's open to port scanning, it represents a security risk because people can just hack away at this during office hours and after office hours and those kinds of concerns, and the general kind of concerns that you're used to hearing about when people talk about RDP. Now, what PIM and just in time allow us to do is to open up this RDP connection for a particular user. So it maps a particular user over here to a particular VM over here. And then it says, as it says just in time, it allows that communication just for the time frame specified. And so you end up having to couple three things together. And that is the user over here, the VM over here, and the specific time frame through PIM here. And so now the authentication pathway becomes the data science user over here at home behind their domestic IP, through the VPN client, the corporate VPN client, they get an IP address from the pool of IP addresses specifically for data scientists. They go through the firewall here with the IP addresses whitelisted. they go to the Active Directory so they can get access to the portal authenticated there. Then once they get access to the portal, they go to their virtual machine and they asked to connect. Again, this time they don't select Bastion, this time they select RDP. And then the next layer of authentication is it goes through PIM, and PIM makes the check which says, is this user allowed on this VM at this specific time? So that's the next layer. And if the answer to that question, all three of those questions are correct, then the user is allowed to follow this RDP path through here to our subnet, our segregated subnet where all our VMs live, and then they can authenticate again here. And so this PIM and JIT replace Bastion. It pretty much does exactly the same thing. It provides a layer of security in a slightly different way, but it still provides that level of security here. And what it allows us to do is it allows us to use RDP so that people, the users here at home, can have their full RDP experience, which doesn't really, I mean, I was looking at it and it doesn't really make that much of a difference if you're only using RDP for a short time to get on the server to do something specific. But if you are there all day, then it can be a bit wearing. So this is a much better user experience and keeps the business happy, and it keeps cybersecurity happy from all of the layers of security through VPN, through firewall, through Active Directory, through time-based security, and through user authentication. So those are the layers of security and the layers that you have to go through the cybersecurity we're talking about, and we've secured it at each of the layers. So from this point of view, everybody seems happy right now. So after a while, again, cybersecurity is happy at this point, but the business now start to say, well, you know, this works using these VMs here. This works, but it's not the best. And we were saying, well, okay, what is your issue? And they go here and they say, well, look, when we were working on site in the corporate network, it looked like this, but some of these servers and workstations on the corporate network were specialized. They ran. We had servers which ran Jupyter notebooks, for example. We had servers which ran, which were GPU specified, so we could run our data science models. And we had collaboration servers, so we had Jupyter Labs on some other of these machines. And we've lost all of that capability now. And all we have is the VMs that you've given us inside here. And we can probably do about 80% of our work. And so for the first few months of COVID, it was okay, you know, because you could get about 20%, about 80% of the work done. But as COVID went on and other reports and other work needed to be done and other things needed to be modeled, and we got to the stage where we just couldn't wait any longer, that's when the business started to get a bit of a fear of, well, you know, our data scientists are telling us that they don't have these things in the cloud, and some of that work that they're looking to do that we've postponed further back in the year because we all thought, you know, it would all be over by the summer kind of thing. That deadline has come and gone, and it's clear that we can't continue with the architecture that we've got because we just can't do our work with just desktop machines, and we are missing these servers. So what we did at that stage is we said, okay, I hear what you say. So what we did was we introduced another layer here. And this layer here contains another subnet within our virtual net, again with network security group attached to that subnet, that allows us to allow or disallow traffic. And what we do here is we only allow traffic from the subnet which has our VMs in it. So the only place that you can get to this DSVM, and a DSVM is a data science virtual machine. And so in here, these represent the kinds of machines that the data scientists had within their corporate network that allowed them to do the work that they couldn't do here on their VM. So this data science VM contains things like Jupyter notebooks, it contains things like Jupyter Labs. It's a big beefy machine. It's got multiple cores, it's got gigabytes of RAM, it's got GPU, it's got all of that kind of thing that they were missing. And here it only allows traffic from the Azure cloud. So we're keeping cybersecurity happy, because again, if we follow our well-worn path now that we'll all be used to, we have our data scientists over here. They go through the VPN, they go through the Azure firewall, Active Directory, PIM, that all stays the same. So that VM, this time they're allowed to RDP to here. So that's just exactly the same as it was before. But now from here, what they can do is they can, from here, RDP, and RDP was, or SSH, depending on the type of server they have. Some of these servers are Linux-based, so they SSH in. Some of them are Windows-based, so they RDP in. And here, RDP and SSH wasn't an issue for cybersecurity at this point, because the network security groups here and the network security groups here on the subnet only allow traffic here. And so there's no way to attack this RDP SSH route from outside, from the public internet. There's no way to attack this. And so cybersecurity, we're quite confident about that. And then we have our corporate data over here, again with our private link, and we can bring data either through this mechanism, either to here, to the data science virtual machine, or to the data science virtual machines that we have in the cloud here, as we had previously. So this looks like it keeps everybody happy. We've still got the security route that we had through all of the layers. So we still have, so those 4 layers that we had are still secured, as InfoSec tell us that we have. We have added another layer, so we now have 5 layers, and so we need to secure it. We have SSH and RDP here, which normally would be an issue for cybersecurity, but our network security groups here and here only allow traffic through there, and so that's not addressable from the public internet. So InfoSec are happy that we have secured that 5th layer, and everybody is happy with this architecture, or so we thought. The issue that came up was one from cybersecurity, and they said, well, they're not happy with this, with the DSVM. And we said, well, what do you mean you're not happy with the DSVM? We have secured it. Okay, we added that extra layer, but sure, that extra layer is secured in the way we spoke about. Why are you not happy with it now? And what they said was that when with the route through this virtual machine here, through this private link to the data here, that ensures that this person here authenticating goes to the data here, and the authorization says that this person here in this virtual machine can see the data here in the corporate data store. But by introducing the data science virtual machine, what can happen is this person here can travel through this private link, can authenticate against the corporate data store, can bring the data back here, has to work on it on the data science virtual machine because, say, for example, it's a large amount of data, or the work that they're doing is compute intensive, and so they just don't have the raw number of cores that they need here on their virtual machine in order to do the work, so they do the work here. Now, within this segregated network here, where we have the virtual machines, one of the rules that we've got is we don't allow side-by-side communication. So data that this person here brings into the cloud through that route cannot be viewed by anybody else in the segregated subnet because there's no side-to-side communication. But if this person travels this route and authenticates and brings the data back to the data science virtual machine, everybody else in the subnet can see the data when it's on the data science virtual machine. Now, the way we worked the security meant that that data couldn't be removed. You couldn't get a hold of it, and you couldn't take it anywhere. You couldn't publicize it, but still, cybersecurity made the very valid point that some of that data maybe they didn't have a example they could show us, but it is possible to have brought through corporate data that this person could see that this person was not allowed to see. And although the person can do anything with the data, the very act of being able to see it shouldn't be allowed. And so this idea of having this subnet with a virtual machine and this subnet here with DSVMs in it, I mean, obviously I just got one, but you have as many DSVMs as you want. This architecture of everybody being able to see everything, everybody in this subnet being able to see everything in this subnet wasn't allowed by InfoSec. So they complained about that. So what we ended up doing was we then said, okay, we'll take that on board. And so we have the same, so we didn't introduce another layer. We still have, this is our fifth and last layer here. But what we did was we segmented both the subnet, which contained the virtual machines, and the subnet, which contained the data science virtual machines. And we segmented them by usage and by data science initiative. So each of these people here are working on a particular initiative, right? And so what we do is we group everybody who's working on particular initiatives. And if they work on more than one initiative, then we create bounded contexts around all of the initiatives that everybody is working on. And what we do is we ensure that everybody who is working on all of the initiatives within a bounded context is allowed to see all of the data on all of the initiatives. And once we're satisfied with that, we segment their virtual machines into a subnet. We create the data science virtual machines that they need in order to complete that data science initiative. And we have that in a segregated subnet over here inside the data science virtual machine subnet. And again, we have SSH or RDP communication across here. Cybersecurity are already happy with that because it's not addressable from the public internet. And we have network security group rules here and here, which mean that this subnet can talk to that subnet, but you can't talk this way vertically, and you can't talk diagonally. So the virtual machines in this subnet, which are allowed to use this data science virtual machine, can't see that data science virtual machine this way. These people cannot talk to these people. This data science virtual machine can't talk to this data science virtual machine. So both horizontal, vertical, and diagonal communication is limited to the subnets that you are allowed to see. And we just replicate this, these two subnets, we just replicate those virtual machines and data science virtual machines here as many times as we require. And this ends up being pretty close to keeping everybody happy now. So we've got cybersecurity happy. We've got the business are happy because they've got their big machines, and everybody for a while is happy. And we at Done Coding Limited, we're happy as well. And then time passes, a little bit more time passes, and suddenly the business say over here, well, we're not really happy about this situation because we have these big beefy machines here, and thank you very much for that. And that works okay for when we're using the CPUs, because what we're doing, the calculation that we're doing on the data is compute heavy. We've kind of solved that problem. But the next problem, and one of the other things that we use that for, is not only because the compute is CPU intensive, but also because sometimes we are looking at a lot of data. And this route here is really slow. And we have to bring gigabytes up through here into the DSVM in order to use it. And we have to push gigabytes backwards and forwards along this link. And when you've got many data science initiatives doing that, this is really slow and cumbersome. So after a while, we start to run up against some of the limitations for the business. And so what we do at that point is we say, right, okay, we understand. And so what we're going to do is we are going to solve that problem for you by bringing the data to you. The Azure cloud is very fast internally. The network is very fast internally. So what we're going to do to make that happen is we're going to keep this part the same as it was before. So everything right up to this part here stays the same. Well, what we'll do is we'll have a data lake store. And what we'll do is we'll use Data Factory, and on a frequency that works for it, on a frequency that works for everybody, what we'll do is we will pull various pieces of data from the corporate network here using Data Factory, and we'll push that into Data Lake Store here. Now, what I've done here is I've been not so much lazy, but what I do is I have encapsulated the way Data Factory works just in this one icon that sits in this barrier. But what I want people to understand is that it doesn't quite work like this. It's not a case of nothing from Azure reaches in past your firewall and drags the data out. This is actually a two-part process. And there is a Data Factory worker that sits on this side of the boundary on your network. And provided it can see the server that the data is on, that is fine. And the two halves of Data Factory communicate with each other after having authenticated each other with certificates. So what actually happens is the one side of Data Factory says to the other side of the Data Factory, I know nothing about what this network looks like down here, and I don't know anything about the data, but please give me the data that this certificate says that I am entitled to. And the other half of Data Factory that sits here behind your firewall says, yes, I know what it is you want, just let me get that for you, and then hands it off after authenticating with certificate. So just to be rest assured that there's no service in Azure that reaches in past your firewall and grabs your data. And Data Lake store here, you can think of Data Lake as being a distributed file system. So it works exactly the same way as a file system, and you can secure it in the same way. You can say this data science virtual machine can only reach this particular directory in the distributed file system, and the children underneath this directory. It can't see everything. So it could all be secured just like a normal file system. And so what you've got here is our ability, firstly, to bring all of the data that the data scientists need to this side, to the Azure side of the firewall, so that they can read and write large quantities of data very quickly around this route. But at the same time, it could be secured in here such that the users of the data here on this virtual machine who come through this data science virtual machine to the data lake to pull data out can only see the data that they are required and able to see, and the same with this data science virtual machine down here. And this ended up pretty much being the final story. So just to quickly walk you through the actual finished evolution of the architecture. If you remember, we started off with just a simple VPN link from your computer in the house to the data at the back end for the corporation. What we ended up with is this architecture here. I'll just walk you through it finally one more time. So we have our data scientists here at home with their virtual machines, with their own domestic IP addresses. They then, through the VPN client on the machines, they log into a VPN client. They get an IP address from a pool that only data scientists can pull from. With that IP address, they're then allowed to go through the firewall where that IP address pool has been whitelisted. So they can get to Active Directory, where they can authenticate their user accounts to authenticate them as being allowed onto the Azure platform. Once they're allowed onto the Azure platform, they select their virtual machine, which is now in a data science initiative isolated network, which doesn't allow side-to-side communication either within the machines or within networks here. Once they have selected that virtual machine and they say, I want to connect to it via RDP, then that's where PIM and JIT comes in, and it authenticates that this user here is allowed on that virtual machine there using RDP at that particular time. And if that passes, then this user here can RDP through to their virtual machine here. The user can't have side-by-side communication, so can't see anything that's on this machine, and anything in this network can't see anything that's in this network here or this network here. The only thing they can do is traffic here to the data science virtual machine subnet, where their big beefy servers are for large-scale data manipulation and large model scoring. Once they are in this data science virtual machine within this network, they can then access data that is in Data Lake Store, and they get that, and that is authenticated just like you would with any other file structure, so that they can only see the data that they're entitled to see. And then they can pull that, they can read and write large amounts of data across the fast Azure Cloud Network in order to get their work done. And that data gets there by using Data Factory here, which the two halves of Data Factory authenticate with each other using safe certificates. And that data travels this route into the Data Lake Store using this private link here. And so once we finally had this architecture that involved over, actually quite quickly over a number of weeks and maybe a couple of months to evolve this architecture, this is the architecture that we ended up with, and we supported our data science team in the cloud with cloud-based VMs, PIM, compute, and storage, all in the cloud. And we've reached this stage now where the client and the enterprise are talking about not moving back to office-based to a mandatory office-based system when if we are given the all clear at the end of June and things go back to whatever normal looks like. This enterprise is saying this architecture here works so well that actually we won't ever go back to mandatory employees have to be in the office. It'll be high days and holidays where they have to come into the office, or at the users at the employee's discretion if they want to be in the office, because it's nice to have the kind of office banter and the crack's always good. You can go in when you want, and if you've got meetings, you go in if you want, but otherwise you'll just work from home using this architecture here. So with that, I'm pretty much finished explaining the architecture and the evolution, not just the architecture, not just the finished architecture itself, but how we actually got there, how we balanced both the business needs with cybersecurity needs, and what we ended up with. And so with that, I'd like to kind of hand over to Sarah now, and we've got the last kind of 5 or 6 minutes where I'd be happy to answer any of your questions that you've got. And as we kind of moderate that and go through that, I'll just move on to that slide that Sarah asked me to show at the end. So with that, thanks, Sarah, and I'll let you kind of take over again.
Great. Thank you so much, Gary. And thank you for the presentation and sharing your thoughts with us. It was very interesting and informative to hear about the way that we've seen how cloud can be a great resource to help enterprises maintain data science business as usual in the face of unprecedented disruption. And Gary's also demonstrated how we've seen the tensions that can arise between business and cybersecurity. And, one great lesson to be learned from that is that the discussions are always best had prior to any incidents as well. While it can be challenging to recommend resources as the technology has changed so fast, Gary has recommended azuracharts.com as an online resource that can be used to track trends in this area as well, if people would like to explore that after this talk. We'll now go on to Q&A. I can't see any questions right now in the chat box, but one that I would have, Gary, is, we traditionally think of security issues around data, but, as you explore the area more, we can see that there's three areas perhaps in particular. There's your data, then your IP, but also your processing power as a company as well. You talk about data, we would presume that's customer data, but was that the area that was of the main concern in InfoSec, or did you have other concerns, other areas of concern?
Yes, we have a number of areas of concern. So there is data that we are required by law to guard, and so that's quite straightforward. It's like, here's data, and only you can view it, and it's as simple as that. And then we have data where we have to be careful with it because of GDPR, with regard to private citizens. So, for example, we have video captured from the roads network, and that you can perform. That video shows vehicle registration marks. From the vehicle registration marks, you can get the registered owner, and so that is privately. It's personally identifiable information. You can identify an individual person from that information, and then so you have to guard against that from a GDPR point of view. So there's that to contend with. And then in the end, there's data